This video will cover section 4.3, right triangle trigonometry. The objectives of the section will be to evaluate trigonometric functions of acute angles and use a calculator to evaluate trigonometric functions. Also to use the fundamental trigonometric identities and to use trigonometric functions to model and solve real-life problems. In this section, we're going to introduce the trigonometric functions from a right triangle perspective. So in the previous section, 4.2, we were using the unit circle to study the trigonometric functions for the values of those functions for the common angles. So now we're going to use right triangles, and if we call it a right triangle, it must be because one of the sides is exactly 90 degrees. You know that it is 90 degrees because you could see the box right there. That implies that it is 90 degrees. And the side that is opposite to the 90 degrees, it's always the longest side of the triangle, and that is what we're going to refer to as the hypotenuse. So in this case, the angle in question is going to be theta, which we have here. And the side that is opposite to theta is going to be something like if you were trying to throw a basketball from there or shoot a water gun, it will go straight into that side. So that is always the opposite side. And so the remaining side that is not the hypotenuse or the opposite is going to be called the adjacent side. And also that happens to be one of the sides of the triangle that is also a side for the angle. It could be the initial side or the terminal side. So that will be, it's forming the angle, it's part of the angle, that will be the adjacent angle. So, I'm sorry, side, adjacent side. So we have that, adjacent side, opposite side, and hypotenuse. Using the lengths of the three sides that we just discussed, we are going to form 6 ratios that define the 6 trigonometric functions of the acute angle theta. And so just to remind you, in section 4.2, we were using the unit circle, and we were, for example, here that angle will be pi over 4 radians, this one. And we know that the coordinates at that point with respect to the unit circle were the square root of 2 over 2 and comma the square root of 2 over 2. But in reality, using the unit circle and the points is also like having a triangle, and that will be the triangle in question. So I'm going to draw that triangle here. And we have here the same angle. And let's see. The longest, remember, that is the hypotenuse. So if we are talking about this angle here, the side that is right across from it is the opposite. We're going to use O and OPP for opposite, for an abbreviation, and the other one will be adjacent. So we're going to use the abbreviation ADJ. So just to remind you, sine, we don't really use the full word. We might say sine of theta. And so when we were discussing triangles, I'm sorry, the unit circle, that was the y coordinate, which will logically be that one, right? So based on the definition with the unit circle, sine of theta, and this is theta, will be equal to y over 1 because it was the unit circle. But then we extended that concept to bigger circles and we say it will be y over r. Okay, so now what we're going to use for sine in terms of opposite, adjacent, and hypotenuse, we're going to say opposite, that will be taking the place of the y, opposite, over, and instead of r, this is r right here. Instead of r, we're going to use the hypotenuse. Okay, for cosine, with respect to the unit circle, we define the cosine as the x coordinate over 1 if it was a unit circle, or over r if it was a bigger circle. And so in this case, this is the x, which now on our triangle, it's actually the adjacent side. And so we will use the adjacent side divided by, instead of r, we're going to use the hypotenuse. Okay, and for our tangent, in terms of the unit circle, it was defined as y over x. So for our triangle example, y is going to be the side opposite, and x is going to be the adjacent side. And that is how we will find the tangent of this angle, theta. So remember, cosecant is the reciprocal of sine, so that will be equal to the hypotenuse divided by the opposite side. So we are flipping or interchanging the numerator and the denominator. For secant, abbreviation is SEC, and that will be the hypotenuse over adjacent, the reciprocal of this one. And finally, for cotangent, that will be the reciprocal of tangent. So it's going to be adjacent over opposite. Here we have the same ratio. So we have opposite. We're using the abbreviation OP double P, and then for adjacent and for hypotenuse. So those are the abbreviations. And we have the exact same ratios that we discussed on the previous slide. So let's get to the examples. And for our first example, we do have a right triangle. We are given 2 of the sides, and we need to find the third side. Although that's not the main question, we're asked to find the 6 trigonometric values or functions, and so that implies that we need all 3 sides. So we're going to be finding the hypotenuse, but before we do that, let's go ahead and define the sides here that we have. So if the angle theta is here, 4 will represent the opposite side, and 3 will represent the adjacent side. And of course, hypotenuse, but remember we use the abbreviation. Okay, so by the Pythagorean theorem, and just to refresh your mind on it, we're going to say that C squared is equal to A squared plus B squared. And since we want to find what C is equal to, we take the square root of the whole on both sides. And of course, if this is square and we take the square root, that does cancel out. So Pythagorean theorem, we'll have C is equal to the square root of A squared plus B squared. For this triangle, we could assign the variable A to the adjacent side and the variable of B to the opposite side. And the hypotenuse always has to be C. So, and that is the one that we are looking for. So we have that A is equal to 3 and B is equal to 4. And I know this looks like a 6. I'm going to fix it. So that is the variable B. Okay, so for the formula, a squared plus the square root of a squared plus b squared, we are going to substitute the value of a with a number 3. So 3 squared plus 4 squared. We substitute b with a 4. And before you could add the numbers or take the square roots of the numbers, you have to square the numbers. And so that will equal to 9 plus 16. Then we can add the numbers. So it is 9 because 3 squared is 9, 3 times 3, and it's 16 because 4 squared is 16, 4 times 4. Then we add the numbers, and that is equal to 25, which is great because it has an exact square root. So C will equal to 5, which is the square root of 25. Now, the answer could also be negative 5 because negative 5 times negative 5 is equal to positive 25. But in this case, we're talking about a triangle, so we're going to just stick to the positive solution. So the hypotenuse is going to be equal to 5. Adjacent side is 3 and opposite side is 4. Now on the next slide, we have a little bit of space, but I'm going to go ahead and draw the triangle. Okay, so here's theta. The hypotenuse here is equal to 5, and I believe I'm going to have to look at it again. Okay, adjacent is 3. And the opposite side is equal to 4. So let's see. For sine, we're going to have opposite, which is 4, divided by hypotenuse, which is 5. For cosine, we're going to have the adjacent side, which is here, and that is equal to 3, divided by the hypotenuse, which is equal to 5. For tangent, we need the opposite side, which is, remember, is the one right across from the angle, is 4. And adjacent is the side that is actually making that angle, so 3. Now, we already know that cosecant is the reciprocal of sine, so we just need to flip our numbers. So this is going to be 5 for hypotenuse, 4 for opposite. And here for secant, we're going to use the reciprocal of cosine, which will be 5 over 3. And finally, for cotangent, the reciprocal of tangent, that will be 3 over 4. And there you have it, all 6. What we have here are two triangles, two right triangles. And so therefore, the biggest angle is 90 degrees, or pi over 2. So if the triangle on the left, the second angle is 45, and so therefore the third angle, it must be also 45. 45 degrees. Now, if the two angles are equal, then the two sides, not the hypotenuse, but the two sides must be equal as well. So if we were to calculate what the hypotenuse will have to be, that will equal to, and let's go ahead and do that using Pythagorean theorem, but instead of using A and B, we will use X. And so that hypotenuse will equal to the square root of X squared plus x squared. So remember, instead of a and b. So that will give us the square root of 2x squared. So that is what the hypotenuse will equal to. And in the case of the unit circle, if we were to say, well, x is equal to 1, then the other x will also be equal to 1. And so if we, oh, and I'm missing the square root here, sorry. If we were to substitute this x squared with a 1, we will obtain the square root of 2 times 1, which will still be the square root of 2. So the hypotenuse will equal to the square root of 2. So now, if I ask you, and remember that 45 degrees is the exact same as pi over 4. So if I was to ask you, what is the sine of pi over 4 or 45 degrees? And it will be based on triangles, and I'm talking about this 45. The opposite side will be equal to 1, and the hypotenuse will be equal to the square root of 2. Remember, we must rationalize the denominator, so we multiply by the square root of 2 again. And then we will have the square root of 2 multiplied by, divided by the square root of 2 times the square root of 2. We discussed that it will be the square root of 4, or the square root of 2 squared, which it will just simplify to 2. And that is the same thing that we got with the unit circle. Now, similarly, there are some properties. We could also prove the ones for 30 degrees. And there is a kind of like a formula that when you have a right triangle, you know already that is 90 degrees. And because the sum of the interior angles of a triangle is equal to 180, if we have an angle being 90, another one being 30, then the third angle must be 60. Now, I want to remind you that 30 degrees is equal to pi over 6. And 60 is equal to pi over 3, okay? So if we turn this into the same triangle that we had for the unit circle, we will come up with the same, not the same, but the like a good explanation. But in fact, we're not really talking, I don't want to confuse you, but if I was comparing it exactly to the unit circle, the hypotenuse is the one that will equal to 1. But just for convenience, I'm just going to let this x equal to 1. Therefore, the hypotenuse will be equal to 2. And the adjacent side, and I'm speaking about 30 degrees, or pi over 6, the adjacent side, it will just be the square root of 3 times 1, so it will just be the square root of 3. So if I ask you what is the sine of 30 degrees, you know it will be the opposite side, which is 1, over the hypotenuse, which is 2. If I ask you what is the cosine of 30 degrees, then it will be the adjacent side, which is here, the square root of 3, and the hypotenuse is this just 2. And so that's what we discussed yesterday, on the previous video. Now, kind of like a fun fact, but it's actually more like a theorem or definition, is that if I switch the angle in question, and now I ask you what is the sine of 60 degrees? Oh, the sine of 60 degrees. So now here is our angle, and the opposite side to that is going to be the square root of 3. That's opposite to 60 degrees. And the hypotenuse is still 2. If I ask you what is the cosine of 60 degrees, That will be the adjacent side to 60. So it will be the one here, 1. And the hypotenuse is 2. And so what we could see here is that the sine of 30 degrees and the cosine of 60 degrees are the same, 1/2. Similarly, the cosine of 30 and the sine of 60 are also the same. And there is a term for that. They're called cofunction trigonometric functions, but I'm not sure if the name is exactly correct, but it's coming up on the next slides. Okay, so going back here, well, to the next slide, we have here the first 3 trigonometric functions: sine, cosine, and tangent. And we have 3 of the most common angles, which is 30, 45, and 60. So we have here for 45. And remember, 45 is the same as pi over 4. And I skipped the pi over 6 is the same as 30 degrees. Remember, the bigger the fraction, the smaller the part. So pi over 6 is smaller than pi over 3, okay? And of course, pi over 3 is the same as 60, so we have sine, cosine, and tangent. And in radians, 60 degrees is pi over 3. So there we have the first 3 for those 3 angles. And don't forget that you already know the sine and the cosine for 4 angles for sure. And that is because you could always draw a unit circle and plot the points like this. So this will be 1, 0. Here we have 0, 1. Here we have -1, 0. And down here we have 0, -1. So remember the angles that I'm talking about will be 0, pi over 2, or 90. And I'm going to zoom in a little bit. We have pi, 3 pi over 2, or 270. And then, of course, 2 pi. And let's see, if we have sine will always be the y value, cosine is the x value. So we are gathering a lot of good information, and that's why I insist that you stay on top of the class. Don't take well, of course you have to take breaks, but don't go days without watching a video, a lecture video. Okay, so now we're going to, oh, and here it is. So remember on section 4.1 we discussed the term complementary angles. And so for complementary angles, those are the angles such as 30 and 60, because when you add them you get 90. And so those two are complementary. Okay, another example could be like 20 and 70. That will also equal to 90. So when you have complementary angles, we are going to have the cofunctions. And that is what we were discussing on the previous slide. So the sine, to give you a good example here, let's say that the theta, we're going to let theta equal to 60 degrees. So then sine of the complement of 60, how do we find the complement of 60? Well, we know it will have to be 90 minus 60, and that is why we use this here, 90 minus 60. And of course, you know that that will give us sine of 30 is equal to the cosine of 60, just like we have it written here. And for those two, it is 1/2. Now, what else are cofunctions? Tangent and cotangent. So for example, the tangent of 30 degrees will be equal to the cotangent of 60 degrees. And of course, secant and cosecant are cofunctions. And also, well, yeah, we cover them all because in fact, the first row we're discussing the same thing. So here, this could be like the cosine of 30 degrees will equal the sine of 30 degrees. And that's just what they are, cofunctions. Not to be confused with reciprocal functions. And we're going to reaffirm that concept in a minute. In trigonometry, a great deal of time is spent studying relationships between trigonometric functions, and we call this identities. So identity is, for example, an identity with numbers. It would be something like 1 is equal to 1 or 0 is equal to 0. That is called an identity. So when we use that word identity and we put it together with another term such as reciprocal, we're referring to the group of the reciprocal identities. And based on the previous section, we were defining, in terms of the unit circle and coordinates, we were defining sine of theta as y. And we could also say y over 1. And cosecant, which is the reciprocal of it, will be 1 over y. Now, in terms of if we just replace y with sine squared, because that's what they equal to, then we will have cosecant is equal to 1 over sine of theta. And similarly, for sine of theta, it will be 1 over cosecant of theta. And so that is what we call the reciprocal identities. So if I have a little bit of space, so we could also say that secant of theta is equal to 1 over cosine of theta. And we could, actually they're here. I don't need to rewrite them. We do have all of them. So secant and cosecant, reciprocal, and so are tangent and cotangent. Okay. Now for the quotient identities, the word quotient implies that there is a division happening or a ratio, a quotient. And so if tangent it was defined as the y over x in terms of the unit circle, or in terms of our triangles, we defined it as the opposite over the adjacent side. But also we could refer to it as the quotient of sine over cosine. And I mean, the simplest explanation is that sine gets replaced with y, and then x gets replaced with cosine. The longer one, we will have to consider, actually, let's do that just to prove it. And we say it was going to be sine over cosine. So if I was to replace sine in terms of opposite and adjacent, I will get opposite over hypotenuse, and cosine will be adjacent over hypotenuse. And so if we do divide those two fractions, remember I described the sandwich rule, it's not a real name. So that would be the product of the opposite side times the hypotenuse divided by, we multiply the two terms in the middle, and that will be the hypotenuse times adjacent side. And so what we could do here is we cancel out hypotenuse because we have one on top, one on the bottom, and they're just factors, they're multiplying. And so we end up with opposite over adjacent. So yes, it is true. They do are the same. Tangent is the ratio of sine over cosine. And also because we know that cotangent and tangent are reciprocals of each other, then we could say that if we flip this two or interchange numerator and denominator, so cosine of theta divided by sine of theta, that will also give us another quotient identity. So the two that look like ratios, those are the quotient identities. We also have here the Pythagorean identities, and here the very first one is sine square of theta plus cosine square of theta. And before I explain a little more of it, let's just clarify this, that if we see sine square of theta, we are squaring the whole sine of theta, as you can see here. It does not mean, don't write this down because it will be wrong, or well, actually, yeah, write it down. Does not mean, it does not equal to sine of theta square. That will be different. And also, you know that sine square theta is like if you had sine of theta and then you multiply it by itself or you square it. That's what it means. And in fact, this is how we have to input it in some calculators. The square, perhaps in parentheses, and then the square outside. So that one, I'm just going to go over the easiest explanation for that. We could use the unit circle. And we know that any point on the circle, it has the coordinates x, y, and if we wanted to write the equation of the circle, which we did when we started the videos for this class, it was x squared plus y squared, and it equals to 1 because the unit circle, the radius is 1, so 1 squared is 1. And so if we just simply replace, we know that x is the x coordinate gives us the cosine values. So cosine square of theta plus sine square of theta, and that is equal to 1. And of course, if we reverse, sine and cosine is the exact same thing because addition is commutative. So they have the exact same meaning. So that will be the Pythagorean identity. Let's see, what else? Well, the next two, they are derived from the main Pythagorean identity. And in fact, we use that so much that, and it's actually very convenient. You might be wondering, why do we have to learn identities? Well, because they actually help a lot to simplify your work. And especially if you have to take calculus, you will be grateful that you learned identities. So let's go ahead and prove that these two are the same. So what we're going to do is we're going to start with the Pythagorean identity, the main one. I call it the lifesaver. So it will be sine square theta plus cosine square theta equals 1. And let's write it twice, actually. And for one of them, I want you to divide by sine squared theta. And as long as we do that to the whole equation, it's okay. All right. Now on the other side of the slide, I want you to divide everything by cosine square of theta. Everything, everything, everything. Okay, now let's discuss the more obvious ones here. Sine square of theta divided by sine square of theta is equal to 1. Then cosine square theta divided by sine square theta. I want you to look at the identities from the previous page. And I want you to look at the quotient identities. And there is one that resembles that one. It might not have the square, but it's still the ratio of cosine theta over sine theta. And yes, that is cotangent. But since we're having cosine square and sine square, we're going to say cotangent square. Now, if we look at the reciprocal identities from the previous slide, we know that 1 over sine theta is equal to cosecant theta. But since we have sine square, we're going to say cosecant square theta. And with that, we were able to manipulate the Pythagorean identity into a different form to write it so that it matches our identity here. So that is one of the variations. That's what we got here. Okay, now let's see what we get on the right side. And if you want to, you can pause the video, try to work it out yourself, and then unpause and check your answer. So, cosine squared theta divided by cosine squared theta is equal to 1, right? We say they cancel. Here, that resembles the quotient identity that equals to tangent, but we're going to use tangent square theta. And for 1 over cosine, we're going to call that secant, because that is the reciprocal. Look at your previous slide, and that will be secant square theta. And so that one is the third, or actually here is the second. The order doesn't really matter here. The second Pythagorean identity. So all three are related. They are the same thing. They're just written in a different way. And we will be using them a lot. So I do suggest that if you are writing all the formulas, making a formula sheet, which will be very convenient for your exam to have them all the formulas ready. Those definitely, this whole slide is very, very important. So the identities, they're very important in this class. The reciprocal identities, the quotient identities, and the Pythagorean identities. So for the next slide, example 5, we're going to apply the trigonometric identities to find what is the value of cosine for part A, cosine, and also for tangent. And what we are given is the sine of theta, and that is equal to 0.6. From our slide with the fundamental trigonometric identities, the only relationship that we have here between sine and cosine is the main Pythagorean identity. Sine square of theta plus cosine square theta is equal to 1. And so that's the one that we're going to use, because on the problem, they are giving us the value of sine to start with. And so for us to find cosine, we're going to need one of those identities, and so it will be that one. We already have the identity written down there, so let's go ahead and actually I need to get the value for sine, which we said it was 0.6. So we're going to replace this part with the number given to us, 0.6 plus cosine square theta is equal to 1. Now, what we're going to do here is subtract 0.6 on both sides, or we could move the number across the equal sign, so you know it's going to do the instead of adding, and I say adding because it does have like an invisible plus sign. Once we take it across the equal sign, it turns into negative, or we can think of it as the inverse operation. And so it's from addition, you go to subtraction, 0.6. Now, this is the exact same thing as if I was saying we are going to subtract 0.6 from both sides. And we know that's going to cancel there, so that's why I don't do that. I just prefer to move things around. And then let's see, what do we have? Oh, and actually I forgot to do a big thing. So this is supposed to be square, because the value given to us is only for sine, not for sine square. So we still have to square that number. So let's keep that here. Now you could enter all of this together at once on your calculator, or you could do it by hand. So to calculate this, first we have to square the 0.6, and that will be positive 0.36. The negative here is coming from here. Now if we subtract those two numbers, we will be getting 0.64 or 0.64. That is the cosine square of theta, and we want to know the cosine of theta. That's the question here, not the cosine square, so we've got to take the square root. And so if we take the square root of cosine square, it will turn into cosine of theta, of course, and the square root of 0.64 is gonna equal to 0.8. So that is the one of our answers. This is the answer for part A of the question. Now to find the tangent, we will use the quotient identity for tangent, and that is because conveniently we already know the sine is equal to 0.6, and we know that the cosine is 0.8. That first one was given, the second one we found it ourselves, and we're gonna put that in the calculator, and the answer is 0.75. So now we have answered the second part of the question. So remember, sine was given to us, is here. This was the answer to part A, and this is the answer to part B. Many applications of trigonometry involve a process called solving right triangles, and you will start to see that a lot in our questions. Solve for the right triangle. And in this type of application, you are usually given one side of a right triangle and one of the acute angles. So not the one, well, and of course, if it's a right triangle, the other one is 90. And you will be asked to find one of the other sides. Or you may be given two sides and asked to find the one of the acute angles. So on the next example, the angle that we are going to be given is called the angle of elevation, which I'm going to explain on the next slide, which represents the angle from the horizontal upward to an object. So angle of elevation, the horizontal, and then upward. So imagine that you are standing here, and you look at an airplane flying by, and I don't know, that's an airplane. And so you are looking at it from here. You're making eye contact, hopefully not with the captain. And so the angle that we form from your line of sight with the horizontal is a line that is parallel to the ground. And so that angle right there is going to be the angle of elevation. Okay, now on the next slide, let me give you an example of the other. So we have here angle of elevation. Imagine you looking up at the airplane. Now for the angle of depression, it's not a sad angle. It's just an angle that is formed with the horizontal. And so let me give you this example here. You're here, and imagine that's some water. And then you make eye contact with a submarine. Yeah. So that right there, imagine the water is the horizontal right here. And then your line of sight, so the angle that is formed there, that will be your angle of depression. So if it's up, elevation; if it's down, depression. Okay, let's move on to the next one. And here we're going to use that concept to solve this problem. And this is example 8. So I'm going to read the problem. Pause the video if you need to, so you could read it yourself or not. So a surveyor is standing 115 feet from the base of the Washington Monument, as shown in the figure below. The surveyor, so here's the person. I'm going to go ahead and point to him or her. And where the surveyor measures the angle of elevation to the top of the monument, and this will be considered the top of the Washington Monument. And he measures that angle of elevation. So it will be the angle that is formed from this horizontal and the line of sight of, or it could be from his foot, I don't know. And that angle is measured at 78.3 degrees. That's given to us in the problem. So based on that, we have to figure out how tall is the Washington Monument. So the question becomes here, what is the height of that monument? And we're going to use the variable y. Now, another important thing about the problem is that they gave us one of the sides, if we form a right triangle, and that is the 115 feet. That is the distance from the base of the monument, which will be here, to the person. So this distance here, it's 115. So it's actually from here to here. Or perhaps, I'm going to erase this. It's probably measured from the center of the base of the monument to the person. And that distance is 115 feet. Okay, so that is what we know, and we want to find this one, and we have the angle here. So with respect to this angle, I'm just going to call it theta for simplicity. With respect to that angle, the side, which we're calling y, which is representing the height of the monument, is it the opposite or is it the adjacent side? It is the opposite side. So this is the opposite side, and the 115 is the adjacent side. Okay, so which trigonometric function do we have in our 6 trigonometric functions? Which one of those requires the use of opposite and adjacent? So it is tangent. Tangent of theta is defined as opposite over adjacent. So let's substitute what we know or what we have. So in fact, I should substitute the angle measurement here. So the angle is 78.3, and for opposite, we are going to use the letter Y, remember? And for adjacent, we're going to use the measurement given to us, which is 115. Now, if I wanted to solve for Y over here, I'm going to do, I need to get rid of this 115, which is dividing the Y. So if I move that number across the equal sign, it will be doing the inverse operation. And the inverse of dividing is multiplication, or yeah. So then we will have 115 times the tangent of 78.3. And that is exactly how we will enter it on the calculator. After you turn your calculator on, it is very important that you set your calculator to work with the right units for the angle measurement. Since our problem gave us the angle measurement in degrees, we have to make sure that we enter that in degrees as well. So to do that, I want you to find a button that says mode. And for this calculator, mode is right next to the second function button. So I'm going to press mode, and you could see something is blinking there. It says normal. And so if I use my arrows and I go down 2 spaces, float is for how much you want to round your quantities. I suggest that you use set float to 9 perhaps. That's a good idea to do, because WebAssign is just so picky. So you use your arrows to move, and then you just press enter. Let's just set it there. So now one more down, and that will make the word radian blink. And so what we want to do is use the right arrow to highlight degree and then press enter, so we can set it like that. Now let's go ahead and quit the mode menu. So we press second and then quit, which happens to be the same button as mode. And now what we're going to do, if you're not sure if this worked, you could always enter the sign of 30 degrees. That's my favorite because it's the easiest. It's 1/2. And it is 0.5, so we're right, we're in degrees. So I'm going to enter 115 times the tangent of 78.3. We close parentheses, and then we press enter, and there we have our answer. And since I set the float to 7, you could see that we have 7 decimals after, or 7 digits after the decimal point. So the answer is 555.31399. So let's see how they want us to round it in our problem. And it does not specify. So if your question on WebAssign was saying round to the nearest foot, the answer will be 555 feet. But if they were to ask you to round, I don't know, 2 digits, or after a decimal point, or to the nearest hundredth or something like that, then of course it will change, so make sure you do round accordingly. So by now you should be able to recognize that when the angle is theta, theta equals 30, like the example I gave you before. My favorite is, because it's the easiest, the sine of 30 is 1/2. And if I want you to memorize something, that would be the first thing I make you memorize. The sine of 30 is 1/2. And So suppose, however, that you were giving an angle that is not as common as 30. So then it will be a little bit trickier. So let's see. So first of all, here they're turning, instead of using 1/2, they're using 0.5. And so let's say that they tell us, well, the sine of some angle that we don't know, and we're going to call it theta, is equal to 0.6. So because we know the first one, sine of 30 is 0.5, and I mean, you might not know that this one yet, but this is the one that could also be written if we rationalize the denominator as the square root of 2/2. And if you know it, that's great. If the approximation is the same, of course, that one. So to make sense of this question, the angle in question here, theta, is, we know is going to be bigger than 30, but smaller than 45. And of course, there's a way that we're going to learn to answer this on the calculator. But for now, I just want you to get that idea that 0.6, this number, it will be here. So that will be the sine of theta, making theta be an angle between 30 and 45.